This is one of the property of squared numbers. You can verify this property by taking two rational numbers. Let me take a very simple number to understand this property. If you have 2 times 5, the whole square, definitely 2 times 5 is 10. So 10 squared is 100. Okay, keep this thing in your mind. I want to show you how this property works for any rational number. So 2 times 5, the whole square means 2 square times 5 square, based on this property. Okay, so 2 square means 2 times 2, which is 4. 5 square is 5 times 5, which is 25. So as you can check, 4 times 25 is 100, which is exactly the same as 10 square, which is also 100. So this property works for any rational numbers A and B. A and B can be any rational numbers. Okay, they are an element of a rational number. We have also another properties of squares. So the third one is A over B, the whole square, is the same as A square over B square, where this B is different from 0, and both A and B are an element of rational number. Okay? This is also another properties of rational number. You can verify this property by taking any two rational number where the denominator is non-zero. Okay? Like what we have seen here, take any number and verify this property. That is left for you to practice it. So this is the third properties of squares. Okay? So having this property, let's see some more examples on squares. The other example, calculate the square of the following decimals. The following decimals. The first one is the squared value of 0.3. The second one is negative 0.5, the whole square. C 1 over 4, the whole square. Now let's see how we can calculate the squared value of these decimals and this fraction. Okay, the first two are decimal, the third one is fraction. So whenever you are asked to calculate the squared value of this decimal, you need to follow the procedure that we used in the previous example. Because by definition, the squared value of a number is the product of those two identical factors. So 0.3, the whole square means 0.3 times 0.3. Okay, there are 2 digits after point, so this becomes 0.09. 3 times 3 is 9, so we have 2 digits after point, so we will have this. Okay, similarly, the squared value of negative 0.5 is negative 0.5 times negative 0.5. As I said before, the product of any two negative rational number is positive. So it becomes positive 0.25. Okay? When we come to the C part, we are asked to evaluate 1 over 4, the whole square. So this means 1 over 4 times 1 over 4, the result becomes 1 over 16. Okay, you can convert this fraction into its equivalent form if you want to express it in the form of decimals. Okay, so this is how we calculate the square of any rational number. Now next, I will show you how you can find the square of a certain approximations. Okay, approximating the square of decimals. Okay, in some cases, the rational number may be given in the form of decimal. So in calculating the squared value of a decimals, we usually use approximations. To make things easier, we approximate the number using rounding off, then we can square it. Okay, so let's take some examples of approximating and squaring at decimals. Approximate the following decimals to the nearest integer, and calculate their inverse, and calculate their squares. Okay, so let's take number like 5.8. Okay, if you take 5.8 using the rounding principle, we can round this number to its nearest integer and calculate the squared values. So as you can see here, 8 is a number greater than or equals to 5. So you can round it to 6. So this is approximately 6. Okay? So according to this example, we are asked to round it to the nearest integer and calculate its squared value. Okay? So the squared value of 6 becomes 36. Okay? So 6 squared becomes 36. So 5.8 the whole square can be approximately expressed as 36. This is not the exact value. This is the approximate value of the squared value of 5.8. Okay, let's take some other example on approximating decimals and calculating their squares. Take negative 4.3. Okay, if you take negative 4.3, consider the number in the tens digit, it's 3. So whenever you round this number to the nearest integer, this is approximately negative 4. Okay, so the squared value of negative 4, is positive 16, because negative 4 square means negative 4 times negative 4. Its result is 16. So we can say that minus 4.3 the whole square is approximately 16. Okay, so this is how we approximate a certain decimal to the nearest integer and calculate the squared value of the decimals. Okay, regarding this squaring, we have one more definition. Okay, the second definition is about perfect squares. Okay, so far we have seen how we calculate the squared values, and we have seen how we call the namings associated with numbers. Okay, squaring numbers. So the second definition for today is perfect square. Okay, a rational number x, a rational number x is called a perfect square. A perfect square if x squared is equals to y, for some y an element of rational number. Okay, so this is the definition of a perfect square. Good. So based on this definition, I will try to show you some of the examples of a perfect square. The first example. One is a perfect square because it can be written as a product of a certain rational number. That rational number is 1 times 1. Okay? The other example of perfect square is 4. 4 is a perfect square because we can find a certain rational number whose identical product gives 4. Okay, so 4 can be expressed as 2 times 2 or 2 square. Okay, 4 is 2 square, 1 is 1 square. And 9, if you take 9 can be expressed as a product of 2 identical factors. Those factors are 3 times 3, which is 3 square. Okay, so these are some of the examples of a perfect square. Can you give me some more examples of a perfect square? Well, you may say 16, because 16 can be written as a product of 2 identical factors, like 4 times 4, which is 4 square. Okay, so these are examples of a perfect square. Good. So these are the examples of a perfect square. Next, I will show you some interesting relationship between a perfect square and the sum of the first consecutive odd numbers. Okay. We said that 1 is a perfect square, right? Because it can be written as 1 square. And the second perfect square that I have shown you before is 4. And 4 can be written as 1 plus 3, which is 4, or 2 square. Okay? The next perfect square is 9, which is 1 plus 3 plus 5. Okay? As you can see here, the sum of these 3 consecutive odd number gives us 9. Okay? This is 9, and 9 is also a perfect square. Okay? So, from this pattern, what do you think the next perfect number? How do you express the next perfect number as a sum of consecutive odd numbers? Good. The next perfect number is 16. It can be written as 1 plus 3 plus 5 plus 7. Okay? So this becomes 16 or 4 square. Okay? So from this pattern, we sense something. Okay? There is a relationship between a perfect squares and the sum of consecutive odd numbers. Okay? So we conclude that the sum of consecutive odd numbers becomes a perfect square, and that perfect square can be expressed in this form: 1 plus 3 plus 5 plus, and so on, up to 2n minus 1. The sum of this consecutive odd number gives us n square, okay, which is a perfect square. So these are some interesting relationship between a perfect square and sum of consecutive odd numbers. Okay, so having this, we have also some other very interesting relationship between the difference of the squared values of a certain consecutive natural number. Here is that thing. Evaluate the following. The first one is 5 square minus 4 square. The second one is 8 square minus 7 square. The third, in C, 11 square minus 10 square. Now here, I will show you how you can easily calculate the difference of the squared values of two consecutive natural numbers. Okay, here, as you can see, 5 square is 25, and 4 square is 16, okay? You are familiar with squaring, so definitely 5 square is 25, 4 square is 16, and their difference becomes 9. Here, I need you to notice something. Consider 5 and 4. If you add them, 5 and 4, if you add them, it gives 9. Okay, keep this thing in your mind. Let's see the second example. 8 square minus 7 square. Clearly, 8 square is 8 times 8, which is 64. And 7 square is 7 times 7, which is 49. If you take the difference between these two numbers, it gives us 15. Now take 8 and 7. Clearly, 8 plus 7 is 15, okay? 8 plus 7 is 15. All right, let's see the third one. 11 square minus 10 square. 11 square is 11 times 11, which is 121. And 10 square is 10 times 10, which is 100. If you take their difference, the result is 21. Now, take 11 and 10, add them, so you will get 11 plus 10, the same thing. Okay, so from this example, I need you to take some relationship between the difference of the squared values of a certain consecutive natural number and the sum of the bases, okay? You can use this way to calculate their difference, okay? But you can also take directly this thing and add them. This works if and only if the two numbers are consecutive, right? For example, if you are asked to calculate such kind of big number, 200 square minus 199 square, you don't need to multiply 200 by 200. This takes time. You don't need to multiply 199 by 199 unless you have a calculator, right? So you can avoid these big calculations and use these bases. You have 200, you have 199, you can directly add them. That gives us the difference between these squared values. So this is simply 200 plus 199, the result is 399, okay? You can use this simple technique to calculate the difference between the squared values of some consecutive natural numbers, okay? So this is all for today. Based on what we have seen so far, I will give you a homework, okay? The first one, calculate the following squares. My first question is I need you to calculate minus 9 square. Okay, minus 9 square. Calculate 3 over 5 square. And also calculate 0.8 square. Okay, calculate this rational numbers, the square of these rational numbers. My second question for you here is, which of the following numbers are perfect squares? Which of the following numbers are a perfect square? Okay, here I will give you a list of numbers, and you will pick a number which are a perfect squares. So my first number is 2, 4, 8, 9, 20, 25, 32, 36, 1 over 4, 9 over 16. Okay, so from this list of numbers, you will pick a number which is a perfect square. The third one, evaluate the following numbers. The first one is take 15 square minus 14 square, 30 square minus 29 square, C, 101 square minus 100 square. Okay, so these are your homework. Let me add one more question regarding approximating and calculating the squared value of a number. Approximate the following numbers. To the nearest integer. And calculate their squared values. Okay, the first one is 7.6. Take the second one, minus 13.1, and C 0.93. Okay, so this is all for today. I hope you got very important concept regarding the squared values of a number. We have seen different things regarding the squares. We have seen some properties and the related techniques in squaring a number. So based on what we have seen so far, I need you to attempt all these questions. These are your homework. So this is all for today. Thank you for listening. Bye-bye.